Okay, just to 8th grade here in Slovenia, and you are studying English, and my language is American English. So far I've given you a couple of talks about the United States, and in April I gave you a talk about a trip across the United States, and you gave me your question sheets. And at the end, I'm going to give them back to you. And this time we're going to talk about the planet that we live on, which is, of course, Mother Earth. And I'm going to have 3 talks to you about this, 2 next year. And as I talk, I'd like you to answer the questions here, like usual. So, we, human beings, we've been to the moon a lot of times. We have stones from there. And we have 2 robots on Mars now. And we have satellites going around Mars. We know a lot about Mars. And last year, we had a satellite fly by Pluto and take close-up pictures of it. And this satellite was going from Earth for 10 years, and it went 4.5 billion kilometers. And all the time, we have the Hubble Space Telescope up there taking beautiful pictures of other galaxies. So why are we doing this? Well, we want to understand other planets, and we want to understand the universe. But most of all, we want to understand and we want to learn to protect and safely live on our Mother Earth. And there's a lot of things about the Earth that we don't really understand totally yet. But if we ask really simple questions, sometimes we can begin to understand a lot more complicated things. So today, we're going to ask 4 questions about the Earth. The first will be, why is there day and night? Why are there seasons like winter and summer? And then, what is a rainbow? What is an earthquake? And who were our ancestors? So the first question is, why is there day and night, summer and winter? Zakaj je dan in noč, poletje in zima? To je moj slovenski accent. These are the 2 really rhythms that determine our life here on our planet. You know, we have 24 hours is 1 day, and 365 days is 1 year. We go from winter to summer. So why is there day and night? The answer is really simple. The Earth is rotating on its axis, and it goes around 24 hours once. And the part of it that is facing the sun is day, and the part facing away from the sun is night. So the Earth rotates every 24 hours, and this is the answer to the first question here. Number 1. And for the half of the Earth facing the sun, it is day, and for half of the Earth facing away, it's night. Now what about the seasons? We know that the seasons keep changing, and now it's gone from winter to spring to summer. Now here's a question for you. Do the seasons change because the Earth is sometimes a little bit further away from the sun and sometimes a little bit closer to the sun? Is that why the seasons change? Yes or no?
No.
Now we know that this is true. The Earth does not go around the sun like a circle, but like an ellipse. So sometimes in the year it's a little bit further away, and sometimes it's a little bit closer. But you're right, that's not the reason we have seasons. As a matter of fact, in the time when the Earth is the furthest from the sun, now this is in miles, it's 94.5 million miles away. It's on July 5th, which is in the northern hemisphere, the summer. So it's the furthest away during the summer. And it's the closest, 91.5 million miles away, on January the 4th. So that's not the reason. The reason is because the axis of the Earth is tilted as it orbits the sun. It's tilted by 23.5 degrees. So it's not going at 90 degrees, it's going a little bit tilted. And you can see that in this picture. The Earth is rotating on the axis from the north to the south pole, but here's the sun. It's tilted to the sun. And so when it's tilted, when the northern hemisphere is tilted towards the sun, then the days are longer and it's summer in the north. But after 180 days, it goes all the way around to the other side, and now the north is tilted away from the sun. The days are shorter, and therefore it's winter in the north. So the more sunlight means it's warmer and it's summer in the northern hemisphere. So in this picture, going back to this is winter in the north because the days are much shorter. So here's some more. So now we've answered that question. Why are there days and nights? Why are there seasons? But when is the longest day of the year?
Last day of the year.
When?
Last day of the year.
The longest day of the year. Is the last day of the year?
That is the najkrajszy.
No, just the doja. Samo 24.
21st of October.
June 21st. For half of the year. And June 21st is very soon to now. The longest day is coming in a couple of days. But in the southern hemisphere, the longest day is in December. All right, is June 21st going to be the hottest day of the year?
No.
No. When is it going to be the hottest?
We don't know.
Hmm?
We don't know.
We don't know, but it usually is happening, the hottest time is usually maybe the second half of July. So it takes time for the Earth to warm up. Even though the longest day is June 21st, then it takes about a month for the Earth to really get really hot. And that's when it's the hottest. So here's the final question. What is the scientific name for the study of planets?
Astronomy.
Astronomy. That's right. And why is the axis of the Earth tilted? Now I'm not going to answer that right now, but I'm going to answer it later. I'm going to tell you why they think it's tilted. Now we're going to ask, what is a rainbow? Kaya Mauriza. Mauriza?
Mauriza.
No. Kaya Mauriza. All right, we know it's one of the most beautiful things in nature. We always go out, we want to see it. But it only happens when the sun is out and in the opposite direction it's raining. So you have to look away from the sun to see the rainbow. So this is question number 4. You have to look away from the rainbow in order to see the rainbow, away from the sun. You have to look away from the sun to see the rainbow. So a rainbow has beautiful colors, red, orange, yellow, green, blue, and sometimes there's a secondary rainbow. See, there's a secondary rainbow there. It's not as bright, and the colors are reversed. From the main rainbow, the colors are reversed. Now there's a lot of myths about rainbows. Like, you know, about this one, about there's a pot of gold at the end of the rainbow. You know that myth? And did anybody here ever find that pot of gold? No. The more you go towards the rainbow, the further it keeps going away. You never get to the end of the rainbow. Even the Vikings, they had myths about the rainbow They thought it was a bridge that connected their world to the gods. And in the Bible, we have a myth about the rainbow. When there was the great flood and Noah saved all the animals on Noah's ark, and the flood was finished, then God gave Noah a message that the flood is finished, you can go to land, and his message was by a rainbow. So the rainbow kind of means a symbol of hope for a better future. But now we have a more scientific understanding of what causes rainbows. So we know that the light is coming from the sun. And the light that we can see with our eyes, we call white light. There's a lot more coming from the sun than we see with our eyes. But if we would take the white light and shine it through a prism, it will break into different component colors. So the color red, orange, yellow, green, blue, and violet are all in that white light. They're all there. And when we put them back together, it would become white light again. And so this was studied by Isaac Newton, and he discovered that each of the different colors of light has a different wavelength. So the red wavelength down here is going much slower than the blue wavelength. And when they go through a prism and they bend or they refract, they're going to bend different amounts depending on what their wavelength is. So if the sun light goes through a raindrop, see here's a raindrop, when it enters the raindrop, it bends, and each color bends by a different amount depending on its wavelength. And then it bounces off the back of the raindrop like a mirror and comes back and exits the raindrop and bends a second time. And so there the red color has bent less than the other color. And from one raindrop, if you're here and you're looking at this raindrop, you're going to see just one color. You're going to see the color that bends and comes right to your eye, which is going to be red. If you're looking at the bottom color, so from each raindrop you see just one color, but the rainstorm is millions and millions of raindrops. And so there from that you see the entire rainbow. Okay? And that's why you see a rainbow. But why do you see a secondary rainbow? Like this one here. And the reason is, in the main rainbow, the light just bounces once off the back. But in a secondary rainbow, the light bounces twice off the back and then comes back to you. So some of the light is lost, and then the colors are reversed. And so the light is not as bright in the secondary rainbow, and the colors are reversed. So just to sum up about rainbows, visible light is white light coming from the sun, and it's made from a spectrum of different colors. Each of these colors has a different wavelength. And the rainbows, they bend, the raindrops bend the colors depending on their wavelength. And from one raindrop we see one color, but from the whole rainbow we see all the colors. So what is the speed of light?
300,000 kilometers per second.
300,000 kilometers per second. He's right. All right. How much time does it take light to travel from the sun to the earth?
8.5 minutes.
8.5 minutes. Close.
Wow.
13 seconds wrong. All right, now, does light travel as fast in water as in a vacuum?
No.
No. So when we say light travels 300,000 kilometers per second, that's in a vacuum. But in water, it travels slower, about 3/4 as fast. And what is the name, now, what is the name for the scientific study of light? It's called optics. So the guys who are studying lasers, that's a big deal now, lasers. They're people who are studying optics. Now here's one final thing about white light from the sun, okay? The sun is putting out a lot of energy. We see a certain thing with our eyes. We see white light, okay? And that white light has all the colors of the rainbow in it. But there's a lot more energy coming from the sun than just the light that we see, okay? And it depends on its wavelength. So the very slow wavelengths coming from the sun are radio waves, and then television waves, then microwaves, then infrared rays, and the really fast waves are X-rays, ultraviolet rays, and gamma rays. Okay? All that's coming from the sun, but we don't see it because our eyes are only focused on white light. There are some animals, like dogs and cats, they can see ultraviolet light better than we can. And now, the original telescope, we were just looking at white light. Now we have radio and gamma ray telescopes, and we're looking at space with those. And we're discovering a lot. So what is an earthquake? Kaya potres. Well, I think you remember that last year there was a big earthquake in Nepal that knocked down a lot of the buildings in Kathmandu, the capital, and killed 3,000 people. There was 2 blocks of land that moved 3 meters and made this big earthquake. There was another huge earthquake in Japan in 2011 in the ocean. And it caused this big tsunami. And then, in this case, off the coast of Japan, the ocean tectonic plate pushed underneath the Asian tectonic plate. It went 30 meters down and it lifted up the ocean floor 10 meters. It lifted up the ocean floor 10 meters, and all that water that was on the ocean floor came like a big wave and washed away a big part of Japan. Have you seen the videos of that on YouTube?
Yes.
It's just amazing. And I think you remember there was an earthquake that we had here on November the 1st. Remember that one?
Yes.
And that earthquake was right underneath our school here, but it was 4.5 kilometers down underneath. And it was considered a small earthquake, okay? As a matter of fact, on the earth, there's 30 earthquakes like that every day. Every day. So there's a lot of myths about earthquakes. Some people think it's caused by hot, dry weather. Other people think the earthquake faults can open up and swallow buildings and swallow people. Okay, but this is all myths. None of that is true. Okay? If we want to understand an earthquake, we're going to have to dig a hole to the center of the earth. Okay? So we're going to start digging here. Here's the guy digging down here in the hole. And we've actually dug a hole 12 kilometers down. Okay? And what do you think, as you go down there, what do you think as you get closer to the center of the earth you're going to find? Is it going to be cold and dark down there? No. Is it going to be hot and shining
Yes.
like the sun?
Yes.
No.
Yes.
Yes. Zemlja.
It's going to be hot and shining like the sun. As a matter of fact, if you go down just 30 kilometers, it's already going to be 1,000 degrees. And if you go all the way down to the center of the earth, the core is made out of solid iron, and it's 5,000 degrees centigrade. And you know what happens to iron when it gets hot?
No.
You see, it starts to shine. So there you're doing this, and then it starts to melt. But look at how it's shining, like the sun. And so in the center of the earth, it's very hot, as hot as the surface of the sun. and it's shining like the sun, but we're not going to see it unless we dig our hole all the way down there. But we can't do that. As a matter of fact, all our tools would melt. And when they just finished that tunnel in Switzerland, did you see that tunnel? The longest tunnel for the railroad train, 53 kilometers long. When they got to the center and they were like 2 kilometers down, the temperature was already, I think they said 50 degrees inside that tunnel. So why is the earth so hot? Because the heat from when the earth was formed has not really disappeared yet. It's still there. And all this heavy material is going down, and there's friction. And that's making heat. And then there's a lot of radioactive material down there too. Now, when the earth was formed, which was 4.5 billion years ago, it formed out of a lot of material, space dust. And now scientists think that soon after the earth was formed, there was a huge comet the size of Mars that was called Theia. Here's Theia here. And it came down and it hit the earth at an angle, okay? And there was, before the earth was hit, it was rotating at 90 degrees and there was no movement. When Theia hit the earth, most of the earth melted and a lot of debris, a lot of stones went out into around the earth and it formed the moon. And because it came at an angle, it tilted the axis of the earth by 23.5 degrees. And ever since that time, there have been seasons on the earth. And that's why the axis of the earth is tilted, because it was hit by a huge comet early in its life. After a couple more billion years, the surface of the earth began to become solid. But just the very surface is solid. The earth is like an egg. And the eggshell is where we're living, on the solid stuff, right? But underneath it's liquid and hot. And all this eggshell is cracked into tectonic plates, like this. And these, so we have like, we're living on the Eurasian plate. But there's an African plate. There's a North and South American plate. And all these tectonic plates are moving, okay? And they're moving because the earth is so hot underneath. It's kind of slowly moving. It's liquid. And it's causing these tectonic plates to move. And they move. See, here they are moving. So Africa is hitting Europe right now. And then they're moving pretty slowly, but not. They're moving all the time. About 2.5 centimeters a year, they're moving. So if you look at your fingernail is growing all the time. You have to cut it, right? That's how fast the tectonic plates are moving. Now, if you would live 1 million years, your fingernail would be very long, and it would move a lot of meters. And these tectonic plates, they move in 3 directions. Away from each other, towards each other, or sideways. So in the middle of the Atlantic Ocean, they're moving away from each other. Okay? And there, it's under the water, but the material is coming up, this hot magma is coming up. You can see this in Iceland. It's coming up, and it's pushing the tectonic plates away from each other. And the ocean floor there is very young. Now, sometimes they're moving towards each other. And where the ocean floor meets the continent, the ocean floor is heavier than the continent. And so it's pushing underneath the continent. We call that subduction. And this is, when that happens, this melts and it forms volcanoes. And this is happening all around the Pacific Ocean. It's called the Ring of Fire. All these are earthquakes and volcanoes around the Pacific Ocean, where the floor of the Pacific Ocean is pushing underneath the continents. Now sometimes the plates collide together and they form mountain ranges. And that's happening when Africa is moving towards Europe and it's closing up the Mediterranean Sea, it's going to disappear, and it's causing the Alps to be formed. And part of that, but a little bit different, was Spain. Spain was a little bit separate, and it came in, here comes Africa this way. Spain came in and collided with the European plate, and it formed the Pyrenees mountain range there. India, in the last 10 million years or so, came in and collided with Asia, is pushing underneath Asia, and is forming the Himalaya mountains, and it's going so far under that it's raising up Tibet, and Tibet is like a plateau that's a very high elevation. Sometimes the tectonic plates slide past each other like they're doing in the San Andreas Fault in California. This part of Western California is going north, and this is going south. And so we like to say, someday Los Angeles and Hollywood, they're going to be located in Alaska, maybe in a couple million years. They're going that way. And someday this is going to slide and destroy a lot of cities there. So here's the take-home points about earthquakes. The tectonic plates are constantly moving, and the driving force is the heat at the center of the earth. And they can move away from each other, towards each other, or sideways. They have a fault line which gets stuck because of friction, and then when that slides like this, it causes an earthquake. Okay? Now finally, who were our predniki? Who were our ancestors? Kdo su bili naši predniki? Everybody, all civilizations have what we call an origin myth. They have an idea of where did we come from. So the Native Americans have that, the Hindus, the Aborigines in Australia, and the Christians in our Bible, we have an origin myth. God created Adam, the first man, out of dust, and Adam was lonely, and so when Adam was asleep, God took one of his ribs and made the first woman, Eve. Okay? And this is a picture that Michelangelo painted of this, of God and Adam. And then, where is this picture? Yeah, the Cistern Chapel in the Vatican. It's in the ceiling there. So here Adam is making Eve. Now these are all myths that we wanted to explain who was the first person. So if we look at it scientifically, who was the first person? The answer is, there never was a first person. There never was a first dinosaur or a first fish. All plants and animals slowly evolved over millions and millions of years. And if you want to understand this, think about it this way. You know that you have your parents, mom and dad. We just concentrate on dad for a minute. And every father had a father. And he had his own father, and he had another father. So this would be your great-great-grandfather. And take a picture of all the, your father and his grandfather, and put them, all these pictures, in a big pile of pictures. Okay? Now there's your picture on the top, and your father's a second one, and now you have all your predniki here as pictures, okay? And now we're going to take one of those pictures, and we're going to look at it. And we're going to see, what did they look like? And we're going to start with the 200th picture, and this would be like 5,000 years ago. And we know what those people look like. They were the Egyptians, the people from Mesopotamia. We also know that we found a man, a European man, who was 5,200 years old, frozen in a glacier. in between Italy and Austria, and he's in a museum now. He's a mummy, really. But he was reconstructed to look like this. He doesn't look so much different than us. Okay? His name was Anzi, because that's the town in Austria there where he was found. But if we would go back 4,000 pictures, we would be back 100,000 years ago, and your great-great-great-grandfather would look more like this. Now, he's looking a little bit different, okay? He had a different color to his skin, and now above his eyebrows is a little bit thicker, okay? But he still would have been a Homo sapien, one of our species. And the Homo sapiens, they developed here in Africa about 100,000 or 200,000 years ago. And there was other types of species, man-like species, that were then living, like in Europe. The Neanderthal was there already. There was a type of man living in China, and even down in Indonesia they found a little tiny guy. They were different species, but between 60 and 80,000 years ago, the Homo sapiens left Africa in migration, and they took over all of Europe, Asia, and they came across to North and South America during the last ice age. If you would go back 50,000 pictures, 1 million years ago, this would have been your great-grandfather, maybe yours. I don't know. All right, now this guy is different enough that he's a different species. This is Homo erectus, and he has a smaller brain. That's the main thing different. His brain was smaller. This fossil was found in Kenya recently, not too long ago. And so we reconstructed. Now, how do we know what these people look like? Because we know what the fossils, and then the artists take it and they put the color on there, and we can make a date. How do we date it? In the rock next to it are what we call radioactive isotopes. They change over time, and we can measure how long they lived by these isotopes. If you go back 3.5 million years ago, this would have been your great-grandfather. Okay? It's getting close to looking like a chimpanzee, and this fossil was found in here around Lake Victoria. We know that there was a common ancestor between the man and the chimpanzee 4 to 6 million years ago in Africa. Okay? And if we go back 6 to 8 million years ago, the chimpanzee, the modern man, and the great gorilla, they had a common ancestor. And if you go back 25 million years ago, we all had common ancestors with the monkey. This would have been your great-grandfather then, looking like this, like a lemur, maybe. So, 40 million years ago, we all had common ancestors. And if we go back 165 million years ago, our ancestor was like a rat, like a rodent. They found this fossil in China also recently, and they think it was one of the first mammals ever. Okay? It had an internal skeleton, and they gave birth inside its body, so they were mammals. But 365 million years ago, our great-great-great-grandfather was a fish. Okay? And this fish got feet on it and walked onto land. But this was also a vertebrate, meaning that it had an internal bone structure, okay? So most of the Earth, we know, is 4.5 billion years old, okay? And for most of the time on Earth, the Earth had bacteria. And then multicellular life started 570,000 years ago. And eventually, all the plants and animals on life developed from these early animals and plants. So we're all relatives. If you look at the vertebrates, the first vertebrates were the fish. But then from the vertebrates came the reptiles and the birds and the turtles. And here the different mammals, they all developed from the first ones. But there's other lines that are all, the different plants developed, okay, the sponges, the worms, everything developed from simple life. And so this is the take-home point about our pregnancy. There was no first person. We developed slowly. Our ancestors were fish that crawled on the land. And DNA and the fossils, they show us that we're all cousins. All the plants and animals are all cousins. We're all related to each other. And so we should learn to protect our cousins. We can learn a lot by studying these simple questions. Everyday things on Earth, like the day and night, and winter and summer. What is a rainbow? What is an earthquake? And who are our ancestors? Sometimes the answers are very interesting. And we can use this knowledge to better understand our home planet Earth and to live in harmony with it and to protect it. So that's the end of the talk. And I hope you enjoyed it.